High above the Earth, a vast ocean of gas blankets our planet, hiding invisible elements inside every breath we take. One of those elements is krypton. It exists in tiny concentrations, making up roughly 1 part per million of Earth's air. Belonging to the noble gas family, this colorless, odorless substance went entirely undetected for centuries. Yet we have found ways to pull this gas from the atmosphere to light airport runways and insulate the windows of our homes. Krypton's defining trait as a noble gas is its chemical stability. It resists interacting with other elements under almost any condition. This isolation is driven by its atomic structure. A krypton atom has an outermost electron shell that is completely filled, leaving no room for chemical connections. Because it cannot share or steal electrons, krypton doesn't burn, it doesn't corrode, and it rejects chemical bonds. If a gas is perfectly invisible and chemically inert, it seems unlikely that humanity would ever detect it, much less find a use for it. The discovery began in 1898. Scientists William Ramsay and Morris Travers systematically dismantled the Earth's air. Working among the glass bottles and wooden shelves of an early chemistry laboratory, they attempted to isolate the atmosphere's components. They used metal tanks and industrial pumps to drop the temperature of air until it became a liquid, a process known as fractional distillation. By slowly letting that liquid warm up, they allowed different gases to boil away. Nitrogen evaporated first, followed by oxygen and then argon. But after the known atmosphere was stripped away, a heavy, unexpected residue remained at the bottom. By methodically subtracting the familiar pieces of the world, Ramsay and Travers forced the air to surrender an entirely new building block of nature. Because this mysterious residue refused to react chemically, the scientists had to analyze it by running a high-voltage electrical current through it. The intense electrical voltage triggers an immediate physical reaction, transforming the invisible gas into a glowing whitish-blue plasma. Through electrical excitation, the current forces stable atoms into a higher energy state. Returning to normal, they release distinct light waves. These spectral lines acted like a fingerprint, proving the isolation of a new element, krypton, meaning hidden. Beyond its light, they realized this new gas was remarkably dense, weighing nearly 3 times as much as the air we normally breathe. The combination of immense physical weight and its response to electrical currents turned krypton into a highly specialized industrial tool. Today, its heavy density and refusal to conduct heat make it an ideal insulator, used inside premium window panes to block the transfer of heat. In photography, sealing krypton in flash tubes allows for the generation of incredibly bright, instantaneous bursts of light that can freeze high-speed motion. That same luminous power is used inside precision lasers, which are utilized across medical fields, scientific research, and industrial manufacturing. Ultimately, krypton's utility comes from its stability. This refusal to interact is the very thing that allows it to safely contain and focus intense bursts of energy. For decades, the world relied on physical objects to define measurements, but metal bars can expand or contract over time, making them imperfect standards. Because krypton atoms are so stable, the light they emit when excited never changes. It produces a mathematically perfect, universal wavelength. This reliability provided a solution. From 1960 to 1983, the official global definition of a single meter was based entirely on the specific wavelength emitted by krypton-86 atoms. For over 20 years, the most hidden, invisible gas on Earth served as the absolute physical anchor for human measurement. Element 36 shows that the most impactful discoveries don't need to be reactive or abundant. Sometimes they are simply hiding in plain sight. If you want to explore more hidden histories from the periodic table, subscribe to the channel. Every element holds a story waiting to be uncovered.